Okay, so chapter 3 is officially over, but I extended it to lesson 3.9 just because I want to show you another way of working with systems of equations. So, as of right now, you know two ways of solving systems of equations. All right? One way is to take the equations and graph them. The other way, which we just learned in 3.8, was to use substitution. It's a long word. And lots of teeth. Okay, so substitution. So that was if you had one that, let's practice with this one. X plus y equals 5, and x equals y plus 7. If you have a variable by itself, x equals, then you know that you can take whatever x equals and substitute it right there in for x. So in place of x, I would put y plus 7, and then I would just write the rest of the equation. So I would combine like terms. Y plus y is 2y, plus 7 equals 5. Subtract 7. I get 2y equals negative 2. Divide both sides by 2. Y is equal to negative 1. Now, once I get that y is equal to negative 1, I can go and substitute that in right there. So x is equal to y, which we just found to be negative 1, plus 7. So negative 1 plus 7, x is equal to negative 6. Now, with that, of course, we would write it as a coordinate. Negative 6, negative 1. That would be our answer. And, of course, you could come back in and check it and find your answer. Sorry, I so totally did that one wrong. That was a positive 6. Negative 1 plus 7 is positive 6. Okay, so if we plug that back in, I've got 6 plus a negative 1, 5. See, that's a good way to check your answer. And x, which is 6, is negative 1 plus 7. So, of course, that works as well. Now I want to show you, if that's substitution, I want to show you what if it wasn't arranged something that looked like that. What if it looked more like, I'm going to take the same equation and just kind of rearrange it a little bit. Let's do x plus y equals 5. And this time let it be something like x minus y equals 7. I just simply moved this to the other side. All right, so if this is the case, I want to show you that there is another method, and it's called elimination. So elimination is just that. It's asking you to eliminate one of the variables. So if they are set up correctly, you could simply add the two equations together, and x plus x is 2x. Now look at this part. Y plus a negative y. Those cancel, correct? They are opposites. So that is gone, leaving just on this side a 12. Divide by 2, divide by 2. X is equal to 6, which is exactly what we got using substitution. Now, if we know that x is 6, I can plug that back into either one of these. 6 plus y equals 5. Subtract 6 from both sides. I just chose the top one just because I liked it. Y equals negative 1. So again, our point written as coordinates, 6, negative 1. So that is our answer. And notice you get the exact same answer using this method as you do using this method. So is one necessarily right and one wrong? No, they're the same thing. It just depends on which way are the equations given to you. So my point in extending chapter 3 to include lesson 3.9 is to just give you one more thing, one more tool, not necessarily more work, but one more tool to make equations work for you. All right? So let's try another one. So let's do, let's try this one. 3x minus 4y equals 14, and x plus 4y equals 2. So right there, something should pop out at you. That if you add these together, so x's to x's, I get 4y. Positive 4y and a negative 4y cancel. so that is gone. So 4x equals 16. I can divide. X is equal to 4. And now that x is equal to 4, I can plug it back into an equation. 4 plus 4y equals 2, minus 4 minus 4. So I've got 4y equals negative 2, divide by 4, divide by 4. Y is equal to negative 1/2. Y is equal to negative 1/2. Now, notice that that is a fraction, which is perfectly fine. It is fine to have a fraction, so don't flip out just because you happen to get a fraction. You can still write it as a point. X is 4, y is negative 1/2. That is your answer. So again, my point to this is, depending on how the equations are set up, depends on which method I would use. You're still free to use graphing, or you're still free to use substitution. If this were my equation, which is what this one was, you could always move this to the other side and get x by itself, which would allow you then to take x, which is negative 4y plus 2, and substitute in up here for that. If I did that, I would get 3 times whatever x is, negative 4y plus 2. Now, don't forget to come back on here and put the rest of this equation on there. Minus 4y equals 14. I would have to distribute negative 12y plus 6 minus 4y equals 14. Combine my like terms. Negative 12 and a negative 4 is negative 16y plus 6 equals 14. Subtract 6. Negative 16y equals 8. Divide by negative 16. Divide by negative 16. Guess what? I still get y to equal negative 1/2, which is what I got the first time. Okay? So I'm not saying one way is necessarily better than the other, necessarily more correct than the other. It's just depending on how it's set up and depending on what your comfort level is. Some people are strictly substitution people, so they want to rearrange things to get a letter by itself, and that's perfectly fine. Some people will jump at the chance to see something set up like this, that whenever you add them together, one of them will simply fall out. So it's just whatever your comfort level is. Okay? Now, let me try one more before we're done. One more. This one. 3x plus 6y equals 6. 2x plus y equals 1. Now, you can solve this by using substitution. You could subtract 2x from both sides and get substitution. That's fine. Or it's also possible to still use elimination, but you have to kind of alter something somewhere. All right? You know that if it's elimination, basically you have to be able to add them together and fall out. So you need opposites of each other. So it is possible, if I take this bottom equation right here, if I were to take and multiply that by something, which I can do, as long as I do it to everything, including this side, then I would distribute and get negative 12x minus 6y, make sure to do it to the other side right here, equals negative 6. It's possible then to add that to my original, which is 3x plus 6y equals 6. So I would come out with, that would cancel. I would come out with negative 9x equals 0, divide by negative 9. Divide by negative 9, x is equal to 0. So if x is equal to 0, now I need to plug that in, let's say right here. So then 0 plus 6y equals 6. Divide both sides by 6. Y is equal to 1. Y is equal to 1. So my point would be 0, 1. And if you solve that using substitution, or you solve that using elimination, or even if you graphed those two equations, which you'd have to do some serious rearranging on that one to get it into slope-intercept method before graphing. So again, my point to showing you 3.9 is to just add another tool that you could use. So I'm asking that you try them using elimination on tonight's homework. You don't have to. You're going to get the same answer if you use substitution. I'm just asking you to try it just to see if you might like it better. Okay? So good luck with that. Graph, substitute, eliminate, whatever is your choice, and go from there. I think we have a couple more minutes. Let me show you one more that you might need to change both of them. Let's try one like this. 4x minus 4y equals 12, and 3x plus 2y equals 4. Now, that one's not going to be as easy if you're just a substitution person. This is why I want you to have the other tools, all right? So this, to get substitution, you have to subtract 3x from both sides and then divide everything by 2, which means you're going to have some messy fractions over here. So this would be one to use elimination on, all right? You can get rid of the x or the y's, whichever one. I would say if you get rid of the y's, hopefully you can see that if you take this one, like you would have to multiply both of these by something to get the x's to disappear. But on this one of them's already negative and one's positive. So that's the key to elimination. They have to have different signs and be the same number. Different signs and be the same number. That might be something you need to write down. Different signs and be the same number. So these are already different signs. So I would pick these, and I could multiply. Sorry, I guess you couldn't see my finger moving up and down. I would pick these because they have different signs. And I could multiply 2 by 2 and get that to be a positive 4, which means I have to multiply everything by 2. So I would have 6x plus 4y equals 8. And I'm going to add that to my original one from the top up there. I'm just rewriting it. Those cancel. 10x equals 20. Divided by 10. X is equal to 2. And if x is equal to 2, I can put it back into one of my original equations. 8, 4 times 2, minus 4y equals 12, so minus 8 from both sides. I would have negative 4y equals 4, divide by negative 4. Y is equal to negative 1. So my answer would be 2, negative 1. Okay? I could very easily have substituted or multiplied both of them by something. Both of them by something. Let me get rid of, well, I guess that went everything. Let's try it again. Let's try to put my equation back up there. 4x minus 4y equals 12, and 3x plus 2y equals 4. Okay, let's real quick look at one that might need more than just one thing done to it. So if you look at these, the x's aren't directly going to fall out, neither are the y's. You can't, you can, just like what we just did right here, multiplying this, but let's say this wasn't available. You could also multiply both of them by something. All you need is one to be positive and one to be negative. So looking at this, I could say, okay, if one's positive, one's negative, let's just make this one positive, this one negative, doesn't really matter. We know that the smallest thing they will both go into is 12, so that means that we would have to times this by 3 and this by 4. Has to distribute to everything once again, so I would have negative 12x plus 12y, make sure you get this side as well, equals negative 36. And then I've got a positive 12x plus 8y equals 16. So that would fall out. I would have 20y equals negative 20. Divide by 20. Divide by 20. Y is equal to negative 1. So that's part of our ordered pair. So now that I have that, I could substitute it back in really to either one. Let's just put it right there. So, oops, sorry, that's a y. So we're going to put it here. So I would have 4x minus 4 times negative 1 equals 12. So 4x plus 4 equals 12. That's a negative times a negative. Subtract 4. 4x equals 8. So x would equal 2. So again, that's the same answer that we got earlier, just we're solving for an additional 1. So either way you go, should be fine. You can always check it, come back in and do, that would be 6 plus negative 2 gives me 4. Again, it has to work in both, so make sure you check both of them. All right? So again, just wanted to give you one more tool to use. Hope you like it. Choose the one that works best for you. Good luck.